Yeah, I just didn't finish. Okay, I'll present what I have so far.
Yeah, just present what you have, and then you can just go ahead and finish it in the course of time.
Okay.
Yeah, so if you can share your screen so that we can follow along, that would be great.
Okay, so good morning, everyone.
Good morning.
Okay, so I selected Kazakhstan as my country of choice. I just chose it because it's something different. I didn't want a common country. So more or less my initial codes are what we were doing in class. So what I did differently was I tried out the pie charts. Let me just get to them. So I tried the pie charts. The first one was just to compare what percentage, with regards to the genders, who's taking more loans, which I found the females were taking, this is 92% of the loans were actually being taken by the females in that country, which I found to be quite interesting because that was quite a big percentage as compared to the male population. Then also I did a pie chart with regards to the sectors. So 82% of the loans being taken were for agricultural purposes, as opposed to the other sectors which occupy a very small amount. So those are just the new things that I did that we did not learn in class. I tried to do also the relationship plots. I wanted to do comparisons like between the days taken between when the loan was posted and when it was disbursed, and between also the time that it was funded. So that was just having a bit of challenge because it meant I have to go to the data and do a bit of work on the data on Excel. Or maybe look for other codes as to how it can manipulate the data on the Excel for me to be able to present it. So I don't think I should present the other things because it's just more or less what we were doing in class.
Okay.
Yeah.
Okay.
Yes.
Before I open up maybe to somebody who might have something to ask, if you can just highlight what it is you are trying to do at some point that made you have to go to Excel, then we can figure out a way to do it just within pandas so that you don't have to leave pandas, because everything Excel does pandas can do. So but this is something that we can explore later on.
Okay.
Yeah. And any other comments from anybody else on that?
Yeah, that was a good attempt, Harriet. Yeah, just remember you keep practicing, you keep, what was your key learning from that exercise?
The key learning is that there's a lot more than what we are learning in class. So you go, you get the codes, then now you have to find out what to put where. Then some things you realize just one small thing can throw you off completely. You keep getting errors. So just the practice and just when you Google and get other codes, how to put them together, also based on what you have learned in class. So it's a bit of a challenge, but I'll get there.
Good.
Yeah.
Thanks.
Thank you. Next person. So Moses, ready to present yours?
Yeah, we can, after the next guy, we can present.
I don't think there's any, and I know Ernest couldn't make it,
Okay.
Lina couldn't make it for now, and Mary, were you able to get anything done? Yeah, Moses, just go ahead, Moses.
Okay. Okay, we'll share the graph. Sorry,
The screen, yeah.
yeah, the screen. Sorry. I don't know if you guys can see the screen.
Yes, yes, it's visible.
Okay. So Justin will start. We made 5 graphs starts. So Justin will explain the first 5 and then, sorry, first 3, and then I'll explain the last 2.
Okay.
Good morning, everyone.
Good morning.
So we started as importing the libraries, as you can see. And then the first graph was bar chart. We traced Rwanda. Then the first graph was bar chart. Then we saw like on this bar chart, it's showing application by sector.
Your audio is fading out. Hello, your audio is fading.
Can you hear us?
Now, yeah, now we can.
Okay, okay.
Then another graph was it's also a bar chart to see who are taking more loan. It's so we saw here it's female who are taking more loan than male. Then another one was the payment interval. So we saw here that people who seem to be taking more loan are the ones who are paying regular. The regular one are the one who are paying, seems to be paying more. Thank you. Let me let Moses to continue.
Okay.
See the Scatterplot? Is the Scatterplot?
Yes.
So we're trying to see the relationship between the loan value and the lending time. So how many times someone was lended the money. So there seems to be a relationship, correct me if I'm wrong, which is linear. So the people who are having more loans given seems to have been given more loans over time. So you find that though they look like they are more like outliers, but there seems to be a kind of relationship. So like you see, there are those four dots at the top. So you can see they have a high loan amount, and also they seem to have high frequency of borrowing. Okay. Then we have the next one there, which is also a scatter plot. Then we have the next relationship there. We're trying to establish the scatter plot between the loan amount, how much was borrowed, vis-a-vis the terms they took to pay. So there don't seem to be any linear relationship there, but we can see some observations. We can see some of the instances where someone borrowed a high value and they paid back within a short time. And we can also see people who borrowed little amount and they also paid over a long duration of time, like 40 months. So they don't seem to be in a relationship, but there is a bit of observation where most of the people probably were paying between 5 months and maybe 15 months. That seemed to have the majority of the people in terms of the duration of time they used to pay. Yeah, so that's what I managed to do. And you asked and it's we seem to have the same trend like Harriet had. Women seem to be borrowing more than the men, so the women seem to be working harder than the men, and that you can see because they are using it. They're putting it in good use because they are doing wholesale businesses. So which is a good thing. They're not borrowing for entertainment or for makeup, so it's a good thing. I think that's it from our side. You asked a question about what we did in Excel. There was one of the columns that was quite dirty, the one for gender. It had like repetition of a lot of female, like I think 20 of them, or rather for one person. So we had to go and try and split and remove the extra data. Otherwise, it was giving us, it will give us wrong information, it gave errors. And then I think that's what was mostly done in Excel that helped us to pull in the data. I think that's it. Date was a bit of a challenge. I wanted to plot a graph with date value, maybe to show the borrowing over time, to understand probably which months people are borrowing more than the other, but I got stuck with the with dates. Yeah, I think that's it.
Okay, thank you very much. Initial comments. So the cleaning up of the columns and all that, actually there was the lecture on plotting with Seaborn. One of the portions shows you how to define a function to clean that up. So you can go back and review that. So you don't have to use Excel for that. And then also for the dates, the class we had last week on Plotly, we introduced the date time index method in pandas, which enables you to format your dates however you want. So you can also review that and figure out how to do it. Other comments, if you can probably clean it up some more, add some cells, markdown, just to document what it is you're trying to do, to explain what it is the graphs are talking about and everything, and then put this up on your Kaggle account so that we can have a record of something that you've done and other people can refer to as well. Those are my comments. And the team, any comments from your end on questions?
Yeah, thanks, Eric. Yeah, so Moses, I think, and Justin, you've done a fantastic job. I think just to encourage you, and I hope I'll be waiting to see Lina's because she's in the banking industry. Yeah, so I think it's important that you have this portfolio published on your accounts. For example, if you go for an interview now to a bank for credit scoring, it's very easy for you to proceed to an advanced level of the interview based on the project you've published on Kaggle. And as we mentioned in our initial course, that we help you build life projects. Yeah, so I'd like to see how we are transitioning this into the next stage, because now what we've done is what we call EDA, exploratory data analysis. We'll be moving now into the application of machine learning models to be able to predict. And you can still continue with this thread under this notebook in carrying on the predictions. So let's see how we can be able to build up on this. And even for those ones who've not been able to do the exercise, I'll really encourage you to do it. So for the sake of publishing this in your Kaggle account. Yeah, so thanks, Eric, for making time and taking them through this crucial stage of data science cycle. And yeah, so we'll be looking to have some exciting projects. So even next week, even those who've not presented, you can be working on something, and we can be sparing about the first 30 minutes just for presentations before the lesson starts.
Yeah, Steve has just joined us. Steve, were you able to get something prepared?
Yes, but I'm logged in on phone.
Uh-huh.
I've been struggling to get through to my laptop.
So then not a problem. I guess we can schedule you then to be one of the presenters next week, like the first half hour.
Yeah, but I had also done Rwanda. I just noted Rwanda.
We shall see
you can
how
do
yours...
another, Eric.
Yeah.
You can change then and do another country.
Yeah, I can try to do another country.
Yeah, just do another country and then prepare your presentation for next week.
Yeah.
That's okay.
Oh, okay, thank you.
Lina, will you be ready by next weekend?
I believe I should.
Okay.
Yeah.
Good. So we should
So
for you
for
and
next
Steve,
weekend, then why don't we say Steve and Lina to prepare for us?
Yeah.
Be ready by next week.
Oh, Ernest, yours will be ready next week as well.
Yeah.
So thank you then. Thank you, people.
Yeah, thank you, Eric.
Eric, I have a question, Eric.
Yes.
On the Scatterplot that shared for the loan amount and the lender account, right? So can we say that there is a correlation, or is it, or is there not?
Between the loan amount and the lender account?
Yeah.
The one that I'm seeing is that the lower amounts tend to have the higher amount of loans tend to have more people lending to them than the lower amounts.
Okay.
That's from the graph. That is what I see.
Okay.
Yeah. Anybody else in the class who has got any other comments on that?
Yeah, I think it's
that's a very good question that we can all discuss and see what are the visualizations telling us, so that we're not just doing visualizations for the sake of it, but they're providing information. So what information are we deriving from it?
Yeah. So for example, Moses, you see this green block on the left, eh?
Yes.
Yeah, so this chart helps you to know there's something called skewness. So it's skewed towards the left. So which means the bulk of the lenders are mostly towards the low value amounts. And then one other thing that we need to start using in data we call outliers. So you have these sporadic figures. So you've got guys on top, so these are outliers. Yeah, so when we go to test, what you're asking is what we call the test of correlation, yeah?
Okay.
Yeah, so that's what is going to be covered in the next level. So for example, there's something we call a correlation coefficient, heat maps. We use linear regression to do that. There's another model called a decision tree classifier, where we're able to test which of these features are more important than the others. And when you're building a credit score model, that's exactly what you use to determine the validity of a borrower before you give them a loan. Yeah, so what you've done here is exactly how a credit score algorithm looks like. So this is the first 30% of the script will look like this. And then now the other 70% now goes into the testing and using of statistical models now to test the accuracy of the model.
Okay.
Yeah.
Okay, thanks.
Yeah, so I think with that, we are done on my part. So until next week when we have the other presentations, James can now take over with the machine learning portion.
Yes. Yeah, thank you, Eric.
Thank you.
All right. Okay, James. So I wanted just to introduce James. So he's gonna be taking us in the next 4 weeks in the machine learning segment of this course. And just to put the connection, as we started this course, I told you about the data science life cycle, where the first level is analyzing and cleaning the data, which is a lot of work. As you've seen, working with pandas and NumPy, it requires a lot of skills, slicing and dicing, comparing the different variables. And that really is almost 80% of the process of working with data that most data scientists struggle with. You notice that when you went to Kaggle, you found data that's already been cleaned. So that's not typical what you'll experience in the workplace. So you're going to extract data from ERPs, you're going to get data from surveys. A lot of that data is very dirty. Now the next step was visualization, which is actually what we call now the detection bit. So when you look at a chart, you are simply able to correlate and look at the different variations in terms of dependencies. That does not have any mathematical input. It's what we call, what you see is what you get. Yeah. So the next level after that, and by the way, for charts, Eric had shared a visualization handbook. Yeah. So in our more advanced visualization classes, what we look at is the different types of charts to use when. Because even with charts, you'll use a chart that will not give you the full meaning of the data. Yeah, so what we've given you is enough to start playing around with different types of charts. We've got a whole spectrum of use of charts and the application to EDA. And I'd like to encourage you to explore that handbook. Yeah, and we'll be giving you more access to a lot of resources around visualizations. Eric himself runs a meetup group that has a passion around visualization. So you can start chatting to tell you the calendar for those meetups. Then you can always be plugging in to join. Now, I wanted to introduce the next level, which is machine learning. So which is the third of 4. Yeah, so the fourth one is the deployment of models. So that comes at a later stage. But after you've cleaned your data, you visualized, now the next level will be to apply statistical models to it. And why do we do that? Because you realize not all data can be deciphered just by using charts. So you need to apply mathematical models in it so that you can be able to find the hidden meaning. And the other reason is machine learning enables forecasting. Whereas charts only work with historical data, there's no way you can start doing forecasting without using machine learning models. So machine learning basically is use of mathematical models applied on the data. And Python is a very robust tool that can be used to develop those. So James, welcome. So James, I've known James for 3 years now. So James is a robotic process automation engineer. He's a graduate of JQuat. And he also has a master's from a collaboration of GE, McKinsey. General Electric and McKinsey run a program for data science. So he graduated last year in November in Johannesburg with a master's in data science. Yeah, so he's done a lot of work around process automation, development of sensors. So machine learning just taps a little bit of the knowledge he has. Yeah, so he also runs a training program for young children around robotics. Yeah, so he's a very rich resource to have, and this particular last session will be covered by him. So one of the things that you'll get from him is a hands-on application. He's been able to automate his work. So even now working remotely from home, he will show you some machines he's automated at the plant at Coke. Yeah, where you can be able to get sensors data, and you'll be able to tell when to start the procurement process of replacing that device before the device breaks down. Yeah, those ones he's been able to build them using open source tools. Yeah, so he's a very hands-on professional. A lot of application of theory put into practice, and he'll be picking up from where Eric has left and to carry on for the next 4 weeks. So James, yeah.
Thank you. Thank you, Timothy. Hi, everyone. I'm very excited to be taking you through this part of the course. Yeah, it's one more step deeper into data science, and it's probably one of I think from what you've seen now, this is quite, there's a lot of more like the revolutionary technology that you're going to use, and it's going to make you make really big steps and big deep steps into maybe making more of into making decisions in your company. And also, like I'll share quite a number of examples where it's not only my company but also individually, like I'm ending up doing quite a lot with data science. Like I'm actually farming now and I'm using data science to do that, so it's quite interesting. So we'll see how that comes in. So so what we'll go through in machine learning, or I think you've seen a number of examples of machine learning, or where it's more like maybe as African, maybe we'll call it a bit weird. Maybe more of the devices acting a bit. It's like there's a person who's actually listening. So for instance, I don't know if you've Googled maybe something, or you are just having a conversation somewhere, and then next time you go on to browse, then you realize you see exactly what you are talking about. Anyone who's had that experience? Hi everyone. Anyone who's had that experience? You are talking something, and then you go online and realize you're seeing adverts of exactly what you're talking about.
Yeah, every time.
Yeah, I think they're getting more and more. We're seeing more and more of that, and I don't think they'll stop. So it's a component of machine learning, and also they quite a number of examples. So many examples. I can, like, I'm sure you've used Siri, or you've used Google. You've used the Google version of it as well. Where you say, okay, Google, search for anything. So this is where all of that comes in, and it's eventually maybe what you've been doing builds up to this now, and we'll see how we go into that. We'll start a bit, maybe we'll progress in complexity, but we'll start with the basics from the simple one we've done, I think, in university in statistics on like y is equals to mx plus c, so, and all the way to going into neural networks. So yeah, so I hope you're excited and eager to see that. So yeah, so I'm sure, so right now people are using a lot of Netflix, and surprisingly Netflix always knows the kind of movies you like. So that's also like another example of machine learning that we're seeing. Those are called recommender systems, and we'll see how those things, those work in the background, and how they're able to precisely guess. Like Netflix has around 98% how correct they are on maybe what they'll suggest to you. They have it's 98% correct, so and it's usually pretty close, or most of the time it will always be correct to get exactly what you want. Yeah, so I think the other thing, maybe with I think you've done a number of video calls, so sometimes so I think my suggestion is we just keep the class interactive. If you have a question, make sure you just you can ask. It's a comment, so yeah, you'll see a lot of new concepts here, so don't be quiet. And also, yeah, because my internet maybe might drop and I end up talking to myself, so just please be active. So next, so this is just what I was talking about. I think the people here are from different backgrounds. Maybe I can just get a feel of what backgrounds we're coming from. Can start with Ernest. What background?
Computer science.
Awesome, awesome. Okay. Next person. Okay, Alice. Or okay, we can just go, please. If you're ready. Steve.
For me, I have a development background, but currently in business intelligence.
That's brilliant. Actually, that's one of the big things we're going to do here. And Harriet?
I have an actuarial background, but I'm currently in life insurance.
Okay, that's brilliant as well. So I think, especially maybe for your career, it's all about the future. So this will be very. Someone else?
I'll go. I have a business IT background, but I'm currently in banking.
Okay. Nice, nice. A lot of bankers here. Yes, next. Someone, Mary? Is M. Kimani?
Hi.
Hi.
I have a background in information science, but currently in human resource management.
Okay.
Yeah.
That's awesome. Can you imagine if you could monitor or you could automate? I think Timothy does that. You can be able to have data science working for you in analyzing how your work or your personnel are performing. And instead of doing that every day, you can have that automated. Okay. Yes.
Marcy here. I have a background in applied statistics with computing, working in a research and development space.
Okay, that's actually perfect. So through this I'm not sure maybe how much you did. So eventually, I think you've already seen with data science, we're doing more like a combination. We're doing a combination of statistics and a lot of computer science. But now the advantage is today's computers are really, really fast. So we're able to do more like do a lot of data crunching or repeat a lot of maths and be able to get results immediately, unlike it was done in the past. So with the machine learning more maybe just to define it, it's now combining an algorithm and using historical data to predict the future. And it's as simple as that. But the other concept you will see with machine learning is you're able to make a system that is able to adapt. So as much as yes, it's given you a prediction for the next maybe 1 year, there's something that will happen and it will actually able to adapt and give you a different, maybe be able to adjust the prediction and give the result. So you can really rely on that. And we'll also see a number of other concepts where you can actually be able to tune the accuracy of it to make sure that you really rely on it. Sometime earlier this year, I had shared like with this, the whole world is currently in, the coronavirus. 4 years ago, Bill Gates had done more like a model analyzing maybe what would some of the biggest threats in the world was viral infection and how it will spread. And the models he had showed that it would kill almost as much as 30 million people. And it was down to how prepared most governments are. Unfortunately, most people or most governments never listened. And that's what we're actually experiencing now. So you see, so we'll make a lot of predictions here, and we need to be able to have confidence and be able to believe in what we actually create. So also, like, I'll show you another example. In the last class, we made a prediction. In the previous cohort, I was taking them through something called forecasting, which we'll go through sometime later. And we're actually able to make a prediction. And though it was at their own risk, but I told everyone to buy Tesla shares. And right now they've actually doubled based on the predictions we made in that class. So yeah, so what we'll do here, you'll see a lot of things and sometimes you'll question them, or they'll tell you something and you don't want to believe it or follow it. So you need to know what exactly you're doing and believe in that. So yeah, so this slide just shows there's quite a number of applications, and like this is basically the same. You've seen everyone here is from a different field or different background, and you see machine learning is applicable in pretty much everywhere you can think of, not only in the sciences but also in art. I'll share some videos. You'll see music being made by machines, and it's still based on machine learning. So yeah, so I hope you're excited to see that. The other thing is the bigger concept of what we are doing here is artificial intelligence, and machine learning is just one component of that. So machine learning, we're going to go deeper into machine learning, but there's these other concepts which will maybe in future in the next sessions, maybe you're going to see some aspects of neural networks, and then neural networks and deep learning. That's where aspects like natural language processing will come in. We also have expert systems. I think a lot of the guys, maybe probably like in banking or even in insurance, you've all seen a lot of this. Expert systems are now like machine learning algorithms that have been taught or trained purely on one subject. We have expert systems in medical fields. So like, have you seen Watson from IBM? Anyone seen Watson? Okay. So yeah, so Watson is one of the, it's a pretty brilliant system. They are truly moving into generalized artificial intelligence, but right now it's being used majorly for medical purposes, where you like give the symptoms and maybe someone has, and it's able to correctly predict what someone might be ailing. There's also under expert systems, there are expert systems in law. So you basically, in law, there's a lot of more like research that's usually done. There is a term they have for it, but normally it takes around 2 weeks. But now using machine learning, now they're doing that in less than 10 minutes and able to finish most of the work they'll have had to do in 2 weeks. So yeah. There's also, I think you've seen a lot of applications. There's a lot of applications happening now in vision. So for instance, one good example that's coming and will come a lot in future is self-driving cars. So cameras give machines a lot of capabilities. They're able to perceive what we see as humans. And like if you look at Tesla, they're doing some amazing things with that. So then like out of almost, I think 4 million vehicles they have, they've had 4 fatal accidents, only 4 accidents that were fatal, and their AI system was able to prevent most of them. And like maybe if you compare the same statistics with the humans, the system is so much better. Most of the classes we've had have joked that sometime in future driving will be legal, and it will be because of the AI systems we are building. So you can imagine, like if you check on the statistics on accidents, maybe in Kenya or globally, for instance, like in US, you have 40,000 people die in car accidents every single year. And maybe back home here in Kenya, we have around 10,000 people who die from road accidents. And those who done like researching this find that it's always the human behind the wheel that has a problem. You might even not have had any distractions, but you just did a mistake and it ended up in a fatality. But now with the advent of AI systems, now you can actually reduce that to almost zero. So picture if you're in traffic and every single car there is an automated car, we'll actually not even have traffic. Because yeah, like if you just analyze maybe what happens in traffic, there's always a human element that's ending up causing that. So yeah, but that will be more advanced. So that will come into something called convolution neural networks, but that will be later. There's also, I think you've used a lot of the examples I've given on Siri and Google, on speech recognition. There's also on planning and robotics. I use this a lot, just to like what Timothy had given as an example. So this, and we use them heavily in the industry, and they are making, they're more pretty much revolutionizing how we do things, because you'd find someone who's been working in a manufacturing setup for 30 years or 20 years, and they'll be making decisions based on their experience, but sometimes, or maybe 30% of the time, they make the wrong decision, or it's too late when they make the decision. But now when you integrate machine learning into monitoring machines, planning maintenances, you end up with a system that's working up almost perfectly. Like we'll now start talking this way, same way the medical, how, like you've seen this term on medical in medical field where they say 99.9%. So I'm actually getting to almost to that point where you have a system that's that reliable, and the time it's off, it was actually planned. So I hope you can be able to do this, and we'll actually be able to have a system that is that reliable and you actually believe in it. Yeah. So I've seen quite a number of presentations you've done right now. So those are pretty nice, and it's from what Eric has been teaching in the past few weeks. So it's good, and what that teaches you is you're mostly analyzing historical data. So like what you are showing, I think that data set is from sometime in the 1980s. So so what you're analyzing there is you're looking at the past, you're doing visualizations, and then normally when you're using such a system, you look at it and then now make decisions based on that. But you see, when it's a human element now that's making now those decisions, it's now based on the kind of experience you've had. So for instance, there were someone noticed that ladies were taking more loans and repaying them better. So if you are maybe a bank manager and you're giving out loans, maybe you'd have a bias towards that, or because you're looking at how best the business would grow. So that is all of what you've been doing was data, I'd consider it data analytics. So where you're just analyzing the data and it's all historical. So in machine learning now it changes, and we start doing like, yes, we've seen what the past was looking like. So how does the future look like, or what should I do in the future? And also what we'll try to do is make sure we're able to tune the accuracy of what we are saying. So for instance, like like maybe like the data you're analyzing, maybe you might be asking, so should I give, I think there's within that data set there is a career column, so you might be curious to know what's the best field that I should, people from a specific occupation, who should I be giving loans, or how many, and then the other thing you also notice is there are a number of aspects. You might be checking on career, checking on the gender, checking on the location, all of those things, and you need to combine all of those and make a decision. So what happens as well is, what happens as well here is maybe when it's two concepts, like you're just checking gender and how much gender and how well they repeat, it's a very easy decision to make. But you realize now in the real world, it's not only one component that's usually that you're usually checking on. There are so many of them, and that makes everything complex. So with machine learning, you're now able to now combine all of those. You'll even be able to look at all the different columns. It might be 200 of them. There are tools and methods of how we analyze that, and you'll actually be able to narrow down and make a pretty good decision and very accurate one. So this is how we do the accuracy testing, and you'll see that. So just to get people to talk a bit quiet. So what are some of the questions you'd like answered from the data set you are analyzing? Like what were you curious about, or what would you like to predict from that? Maybe we can start with Ernest or Harriet. Yes, Harriet.
One thing I wanted to analyze was the duration of time it takes from the time a loan is applied for to the time that it has been disbursed. That was one thing I'm curious about from the data set that I had. Also, in terms of the people taking out the loans, what term most of them taking, and then now based on that, just to compare the two, and also just see with regards to the genders, which genders take longer durations of time to repay their loans. Yeah, and then just such kind of like things. I know from the data we're not able to tell whether maybe by the delay of the loan being disbursed, whether they are able to really achieve whatever they wanted to achieve. I know that's a bit difficult based on the data that we had. But yeah, that's what I was curious about.
Okay, so I think maybe what we'll have in the next sessions, so you can just come up, or the question you have, you create, or you do more like a hypothesis testing. Come up with a question. So probably maybe your question might be, are more ladies being given loans than men? That kind of question, and now you're looking at that, and also maybe trying to predict what would happen in the future, or also maybe given how well ladies are paying back loans or men are not paying back loans, what does the future look like? And now that's where you, maybe as a manager, or if it's now your job, or you'd be able to make a decision on the future and say, like, now from now on we're not giving men loans or something like that, or this is how much, this will be the limit on how much. Like I think there's a group that showed that there's a certain limit that if you go to, then people take a bit longer to pay back. So yes, I think Steve had something. So make sure you note that question down, and it's what you're going to use. You'll use some. We'll try see maybe what the tools we learn today, we can use them to answer that question. But eventually, within the next 4 weeks, we'll be able to answer those questions. Yes.
Okay.
For me, my interest, although the data set doesn't have that, would have been on repayment,
yes.
Which forms the bulk of credit scoring in terms of who is paying, who is not paying.
Yes.
So with that missing, I was looking at the loans uptake in terms of the tenures.
Yes.
To see whether all sectors are taking loans on the same tenor, or which sector is preferring the short-term versus the long-term loans, which gender. Yeah, so that another.
Yeah, I think that's a good one. So like what exactly like what is showing on this graph, so you'll make a decision based on the past. So you'll see, and I think it still happens. We have someone here from insurance, from banking. So it happens a lot. Every time you go there, you all asked 1,000,001 questions on what do you do, background, how much income, especially when maybe it's coming to a loan. Then in the background, there is a machine learning algorithm, and depending on how good it is, it will rate you lower or it will rate you higher. And so that is actually a good one. Maybe from the data you're analyzing, if someone comes in, so once you built your model, you should be able to just pick. You should just pick the different aspects or the different features of a person. So for instance, career, how much they earn, all that. Once you put into your model, it should give you a prediction of how much you can give or not, and maybe how soon you expect that person to be able. Yeah. So I think that's a good one. You can try do that and make sure you answer that within this. We answer that within the next 4 weeks. Yes, Lena. Lena, you're here. Or someone else, please.
Just a question, yeah.
Yes.
What's the future of this predictive analytics and also machine learning, now that you find that some of these companies, like say Microsoft and Oracle, they're able to build already predictive models? You see, like now in the bank, if you want to do a credit scoring, maybe you'll find they've already developed an application for that. If you're trying to do maybe I don't know, a chatbot, for example, they have already built a model for that.
Yes.
So what feature do we have in terms of for us?
I think it's most of the big companies, the models they've used in the past were to sell to the masses. And like now using Microsoft Word, it was they wouldn't make much money if they sold to developers. But if they sold to everyone, then it made more money for them. So they're trying to approach this in the same way. So like they like there's a concept we're going to learn sometime in future on automated machine learning. So that's what they're trying to go for, because if they do that, then they don't necessarily need developers to create the machine learning models. But now with the other thing you'll see as we build these models is they are kind of a bit complex, and a model will work for one place and it will completely be not work for another place. So there is a lot of tuning, and actually most of the work in data science is in tuning the models and getting them to work right, and that they're giving you the accurate results. So that's where now data science, or what we are doing, comes in.
Yeah, I think, can I add, James?
Yes.
Okay, so also what you find in machine learning, there's something we call calibration of models, which has a lot to do with the data that you have. So for instance, in Kenya, we have 3 credit reference bureaus. There is Credit Info, there's TransUnion, and there is Metropole. So all these credit unions, credit bureaus have got different algorithms for credit scoring. And when they go to a client, there's something we call the confusion matrix, which is used to measure the accuracy of the model.
Yes.
So the intellectual property of the bureau actually depends on the algorithm they're using. So you'll find, for example, there's a company called Equifax. So Equifax supplies credit score models to banks globally, but they do struggle a lot when it comes to calibrating those algorithms to local context. So in Kenya, Metropole has been known to have a more accurate model of predicting the ability of borrowers to repay the loans when using local data, because the data is very diverse. So for example, they've collected data from SACCOs, they've collected data from transactions, MasterCard, Visa. So that enriches the model they're using. So Moses, I think just to answer you, there's still a lot of feature for this, and especially because we are using an open source tool, Python, So which are the same tools used by the big technology companies. So the advantage the big technology companies will have is cross-selling and upselling. So they can go to a bank and sell an end-to-end solution. But the bank will need to have a department that can be able to cross-validate the models that they're selling, they're using to the credit scoring. Yeah, so I hope that can give you a picture of what it looks.
Yeah, and exactly on that point, you find a model working today and next month it's not working. So you need, like we said in the definition of machine learning, you need to have a model that is adapting. So machine learning creates, you don't just maybe come up with a formula and you give it to X and you get the result Y. Now it needs to be able to adapt. So like now, for instance, right now everything has changed based on maybe like what's happening with the COVID-19. So your models need to adapt and be able to actually, you need to adapt and be able to make the right decisions given the new conditions.
Maybe to add on that, yes, as much as there will be custom models that come off the shelf, there's a lot that is required in terms of, as Tim said, recalibration.
Yes,
right?
yes.
As even the combination we're using, combination of even other results from other models, just to add it as an extra parameter and see how it compares with the rest. So there's a lot, as much as there's the buying off the shelf, customizing it to the local business and to the data generated within, like for us, a bank. There's a lot that is required.
Yes.
So the future, I guess, is just growing bigger and bigger.
Yes, and also another concept that's coming up a lot is right now there is something called explainable AI. So people come up or use machine learning models and they get a results and they have no idea what happened in the middle, like between input and output. So you need to also to understand and be able to explain why you've had a certain result, or is it that you follow a certain result blindly? So that's also the other question. So yeah, someone else.
Maybe just a comment is for me, I'm open to learning, but I'd be more interested probably in terms of visualization. And when I say this is vision, say for example, I have a friend of mine who was able to make a program that is able to detect anybody in their compound using cameras, and if anybody comes in their house, they're able to, the program is able to send him an SMS, and it's also able to detect who is allowed and who is not allowed to come for them. I saw that very intriguing.
Yes.
I think that would be good. And also another one is there's a scenario where you can use data science to be able to predict who has a possibility of getting sick, particular disease, say like for example cancer, based on observing some maybe X-rays or something that can be able to give predictions of who has a likelihood of getting this particular sickness or something.
Yeah, that's actually very true. Like so a good you've given a good example on cameras. So one might be maybe just like if you picture cameras within a building and they're very like there's 101 cameras there. Having someone looking at it, you just need a minute, like you've seen it in movies, you just need a minute of them not looking and they are all compromised. But when you have an AI model working in the background, you can actually have them analyzing in all these cameras. Like right now we have the similar system in Nairobi, but maybe in China, they even more on that. Where they analyze, they can even do facial detection using the same cameras instead of having someone monitoring the million cameras in the city. They analyze and give you the results. If it's a specific car you're looking for, you don't have to start going through 24-hour videos looking for a specific car in one of the cameras. the machine learning model should be able to go through every single frame in the different videos and give you maybe the location of the vehicle, or maybe even the trail, or which roads it was seen in. So yeah, those are some. There's a lot of applications in machine learning, and they make work easier and more efficient and more accurate. Yeah.
James, maybe I can just add also, because we already have some of these live projects, and
yes.
they are part of our intermediate data science course.
Yes.
We have object recognition algorithms that we are using, and we've developed a software already that does footfall counting in malls. So if you want to know that if someone has walked into a compound, yes, that's possible. Also for traffic, there's a project we are doing for traffic vehicle counting. We've mapped out different billboards in the city, and we are developing a recommendation engine for advertisers to be able to know which street has got the highest traffic at certain times. We have, Uber has open sourced their data. So we've combined that with data of vehicle speeds across the different streets in Nairobi. So we can be able to tell the average speeds of vehicles at different times, and we can know which street has got the highest traffic at what times. So this one we are working with Kenha. Of course, the government has to give us access to their CCTV footage to be able to get the images of the cameras being streamed from there. There's also image recognition. Now, this is a project that's being done by Amazon. There's what you call digital geometry, which is used to recognize images of faces. It's not by coincidence that China is ahead of this, because the facial features of Chinese are almost similar. In Africa, the challenge is the shape of our faces are quite diverse. So it's very hard to do facial recognition in Africa than it is in China, where most of the facial features are almost similar. But that doesn't stop. So there's a project that Amazon is doing. How many of you have heard of Zindi? So there is a Zindi challenge that has been going on for the last 2 years, where they're building a library of facial recognition. So this will be available to developers when that time comes. And then to add on that, there's something called gait recognition, because also how you walk is unique. So there are algorithms actually which can be able to detect, even if it's dark and your face cannot be detected, you can know who was actually walking around your compound. Yeah. So all this is actually done on Python. So at a later stage, we'll introduce the concept of data engineering, where you're able to see how you process unstructured data. And that's really the gist of big data, because most of the data we work with is structured, which is numbers. But now when it comes to unstructured, which is video, images, and voice, the conversation changes. We start talking about different frameworks for processing that data, cleaning. You've probably heard about Hadoop, MapReduce, Spark, and they're actually on Python. So you cannot study those unless you know the Python fundamentals. And then machine learning is now what puts those two bits together.
Yes, so there's a lot of very powerful applications just using the Python that we're going to use today. And the interesting thing is also most of the models there's the math part of it. We'll maybe just for sake of the first principles understanding, we'll look at the math side of it. But then most of these models, there's libraries or functions already made to make it easy for you to use all of that. So you'll do a lot of powerful analysis. And like you said, you wanted to see some visualization of that. So other than maybe on the cameras, so like the graphs we have here, you'll be able to see what you're actually predicting and be able to follow that. So another example here was so you've had this now with global warming, everyone is talking about sea level rising, and what was being looked at some time back was based on how we actually based on the historical data, where will we be in 100 years? And that's why we see So like this part here to this point here is the raw, is the historical data. And then now from this point, now using a machine learning model, depending on which one you use, will give you predictions of what the future looks like. And that's where the alarms come in. And it's always better to be prepared than to be surprised by something. And that's where I think most of the scientists, you're seeing them scream about global warming so that we take action early enough. If you look, I'll share some interesting data on this part, which will be a bit controversial. If you look at, this looks at 300 years back, but if you look at maybe 10,000 or 20,000 years back, you see a very different graph. And if you are to make predictions, these predictions, the resulting line or the predicted line that follows is pointing down. So I don't know, but for those who support global warming, I challenge you to go look at that data from a data science point of view and analyze what's actually happening versus what people are talking about. Then it will really question what maybe you believe in, like versus or maybe what you believe in and versus what the data science will be pointing at. So the other one here, this one here we did in last class, we were doing forecasting. In a different cohort, we were doing forecasting. So with forecasting, we were trying to, it's a bit of a complex thing, because we're trying to analyze time series data and see what it will look like in the future. So this one here is Tesla stock. If you open the Tesla stock right now, so this was around 4th of April, and this is where everything was pointing down. So we did forecasting. We're using something called Facebook Prophet. Most of the big companies actually outsourced their algorithms. So if you look at this is what it was analyzing. So this also looks at seasons. So you can see like there are spikes on a certain intervals. So it will look at seasons and also look at, and you can see even from the prediction here, the same spike is being seen at a certain time. So the data was pointing down at that point, but when we did it, when we did the forecasting, it pointed up. And I challenged people, or more like guys who wanted to invest, you could buy stock then, maybe lose it, or you stand at gaining. If we were to follow the results we got, this will have doubled by around now. This will have gotten to around 600. The most interesting thing is if you look at the Tesla stock right now, it's exactly what this graph was predicting. So yeah, there is this back to what I was saying, that you should be able to make models and be able to believe in them. And if you follow them like this one, now you'll have made quite a bit. You'll have basically doubled what you bought. So yeah. Any questions or comments? Comments, questions? Marcy, you're very quiet.
No, I don't have any questions.
Okay. So now going into machine learning. So what we'll cover, there are different ways of like breaking down machine learning, but how we'll actually break it down is based on these 3 aspects. So we'll look at supervised learning, unsupervised learning, and reinforcement learning. So with this is usually based on how the model or how the data is structured and how you're actually going to learn. So the first and where we start, more like the easiest one where we start is on supervised learning. So supervised learning is a concept where you have very structured data and everything is already named, or you have columns like now going down to the actual data, everything is named and you can be able to everything, all the data that you have has labels and you're able to analyze it very easily. And this you can actually find with things like weather forecasting or maybe population prediction. You've seen like these models where they say that maybe it's as simple as the number of people versus the year and how we've been moving. So like I think that there was a prediction that Africa would have almost, I think, 3 or 5 billion people in by 2050 or 2100. So this is just based on a supervised regression model, and it's just looking at very basic concepts. You can also use this on maybe like weather forecasting, like for instance, like for weather, though maybe when you go deeper into weather forecasting, it's a more complex thing, but given maybe if humidity is a certain level and the temperature is a certain level and they slowly start changing, humidity starts increasing in a certain area, then most likely it will rain. So that's usually very basic predictions algorithms, and that's what we call regression. Also another easy one, like I think everyone here has done a BMI test. So like that one is usually based on a regression model. Like if you are this certain height, you should be around this weight. So that's also one. And given maybe like for that example, it's usually based on given so much data that we've had of healthy people, is where if you're given just the height and the weight, this is where you should be. So that's where regression comes in. It can be very easy concepts, like they can just be simple 2 variables, but then sometimes, or maybe in real life, we have aspects where now you have multiple aspects of like we call it multivariate. So we have multiple columns or multiple aspects that are affecting the final results. So there's a certain extent to where you'll be able to do that with regression, but you'll also see the limits of regression at some point. So then there is another aspect where we do like so other than regression, there's another one called classification. So I'm sure you interact with this a lot. So like right now, if you go to Google and say cats and like you search for cats, you're going to see a lot of cat pictures, and that's with classification. With classification, it's usually trying to divide, or more like classify. Basically, just from the definition, it's trying to classify the data into different elements, and you'll see that a lot. So for supervised, maybe you have data that's already, like there are some models we are going to look at, like given certain features, like there's one called the iris dataset that's usually trying to classify flowers. So given certain features, there's a species it belongs to. So like that's a very basic one, and it tries to do classification. But then also as you get maybe deeper into this, you can do maybe like for guys in banking or insurance, you can do fraud detection, maybe given there's always certain characteristics that are there in a fraud case. So you can train your model and you'll be able to do a classification, like there'll be a very high probability of fraud in a certain class. Or maybe guys in insurance, or maybe in networking, guys in computer science who are in networking. So you might also be monitoring maybe some activity and have a machine learning model that is using classification. So if you see maybe some, so you will classify what is normal and what is not, what is abnormal, and you'll be able to pick when there's maybe some wrong activity that's happening. Yeah. So any other examples you know of that or you probably use this in your field somewhere?
Maybe you can expound on where the aspect of supervision is coming. What exactly are we talking when we are saying it's supervised?
When you're saying supervised, so the data, like the data you get, sometimes it's down to how well labeled the data is. So there is sometimes you just get data that is not exactly okay. By labeling I mean okay, maybe I don't know if I have a good example here, but which one? So like picture, if you have data on like the one I've given on the iris data set. So you'll normally so that one, let me just open it just a minute. So you'll have data that you just given numbers and it's not labeled, so it's for you to just do a classification on where they fall. So they don't have names. Just a minute, let me open it. Okay. So, but basically on these three aspects, they're usually checking on the labeling of data. So for instance, now, like when you, maybe I can give a good example on unsupervised data. So like when you have pictures and they're all jumbled up and you don't know, maybe like you've trained a model to be able to identify cats and dogs, but the specific data you have now of the pictures, they're not labeled, they're all just mixed up. So that will be now unsupervised, where nothing is labeled. It's for you to now just classify based on some features, you classify it separately. So you're able to now classify it separately. But now there's also, for unsupervised now it's the opposite. So let me just share. Okay, so another question, please. Anyone? As I open this one.
What about the deep fake?
Yes.
Deep fake or the deep learning, where would that fall under?
Okay, so for deep learning, that is now okay. They still you'll still get maybe in a certain way. You still get classification, supervised and unsupervised within deep learning, but the method that maybe you use is different. So within this, you'll still have deep learning within unsupervised as well. But now the kind of, with deep learning, the kind of data, the amount of data you have is bigger. And also maybe the analysis tools you're using are different. These ones here, we're going to use basic statistical tools to analyze. Okay. So I was sharing a picture. Okay. Share difference. So with you can see the screen right now. So like for the example I was giving with the iris dataset, you basically have you might have everything, all the data labeled like it is here. So like the final, more like the final result of what class it falls under. But now, when you have just the raw data and you have to classify it separately, and you don't know which one falls to which one, then in this case it will be unsupervised because you don't know maybe which class each one is falling in. But then, yeah. So like this data, before you actually do the classification, it will be just raw figures, and they all in one column. They all in one column, and they no naming. But then when you do the classification, you'll now start seeing everything falling into a certain section. Like there is different classes falling into different sections, and that's when now you'll add the labels into them. Okay, I think when we do more examples, this aspect is going to come out. Okay, so the other one here is on unsupervised system. So like this is now the example I was just giving on, where you have the data is not exactly maybe labeled, but you just have raw data and you have to make some sense out of it. So for instance, now with the recommendation systems, we have the data we have is now like the different users and what they are watching or what they've selected. But then after some time, you start clustering. You'll start seeing that maybe a certain user is watching a lot of content that is, maybe it could be telenovela, or there's someone who always likes action movies. So so that's where the clustering will come in, and you now start recommending system. Maybe you'll now start doing that kind. You'll now start doing recommendations based on maybe what they were doing in the past. And then like same thing on what we were talking on earlier, like with the when you buy one thing, then like I think this happens a lot with Amazon and AliExpress. You'll buy a TV and they'll recommend a sound system. So it's basically still the same thing. Then there's on dimensionality, you're going to see like when the times when we have maybe too many columns, or we're trying to analyze and see which ones are the most relevant. And so we try to we are going to use some tools called PCA to try reduce that and use the most critical ones, or the ones that are most relevant to the final output, or the ones that have the most impact in the final output. Then the other concept is on reinforced learning. Reinforced learning is using algorithms that, so there's a lot of deep learning in this section here, and it's usually based on, it's purely maybe the complexity of the concept in this they're more complex, and there's a lot more data. So most of the deep learning, you'll find it in this section, or even actually probably all of them. And reinforced learning tries to even to actually more like learn the same way a child does. So they'll make mistakes and learn from the mistakes, and then make the right decisions, and you end up with extremely powerful systems on this. Like, have you seen anything on their systems? Like we've seen some like Google came up with this algorithm they call Go, AlphaGo. Have you seen any of that? Anyone? So there's a game in China called Go, and it's a board game, and kind of similar to chess, but it's way much more complex. The only other thing about it is it has endless possibilities in the game. So they actually say that it has more possibilities than the number of stars that are there in the universe. So it's an extremely complex game. And now with supervised learning, Google were able to actually it's actually DeepMind. They were able to actually create a machine learning model that could play the game, and it beat the best person in the world on that. And after that, they actually made another one that beat the AlphaGo 100-0, just based on learning from its mistakes. So a lot of this you maybe see them, especially with the big companies like Amazon and Facebook. They use a lot of these aspects. So I think, like, have you seen examples where you maybe you upload a picture on Facebook and Facebook already starts tagging the people there? Yet you'd never told Facebook that this is who. Yes. Guys, you're too quiet. I'm not sure if my internet is on.
Yeah, we have seen that on Facebook.
We are there.
Yeah. So, yeah, I think it's one of the challenges of when you're using online meetings. Yeah, it gets a bit complex to tell if people are there. But anyway, so these are the three. We'll mainly divide machine learning into these three aspects. So we'll look at supervised learning, unsupervised learning, and then for reinforcement learning, we'll probably do it in a different module. So for this section, we'll mainly focus on supervised and unsupervised learning, and we'll actually segregate them into, starting like today, we'll do a bit on regression, and then next one we'll do classification, then maybe clustering, but we'll now just get deeper with every week. Questions or comments? So yes, Tim. Okay, so is this Ernest, Steve, some question?
No question from my end.
Okay. So the other thing we'll look at is the whole, more like the steps we go through in machine learning. So for every machine learning or maybe every machine learning project or concept we look at, whether it's in deep learning, these are the steps we'll go through. Even on the most basic ones in regression, we'll just do these steps. The only thing is they kind of the iteration gets more, or there's a lot more that as we're going to discuss, you'll see where most of the work happens. So right now you've been dealing with a lot of historical data. So what we do in machine learning, now the whole process, before you start machine learning, it assumes that you've now finally done data cleaning. So all that you've been learning in the previous classes, you've now gone through every single step on data cleaning. So, and you're not sure about the kind of information you're looking at. So, so what you do in this, so the first stage that you do here is a bit of what you've been doing. So there's data cleaning, there's feature selection, there's also something called feature engineering. So depending on the question you have, like the questions we started with today in the data you're analyzing. So depending on what you're trying to answer, there are certain columns you're going to maybe get rid of. There's also columns you're going to create. Maybe it might be a product of two different columns, and so for you to have now an extra column on, or here we call them in machine learning we call them features. So you'll add features to data. So you might start with data that has 5 columns and end up with maybe 7 of them. So there's a lot of that happens. Like with the time series data, sometimes maybe you might have data on a per second basis, and maybe you just want to average everything out and have it on an hourly basis. So you could do that. So in feature engineering, or between the raw data and feature engineering, you'll do of that data cleaning, feature selections, transformations, and then now final selecting some columns to work with. So the other thing you do, and this happens in all machine learning models, you're going to split. So splitting data is usually like we usually split data in machine learning to, like, so you might have, say, like you have 1,000 columns, 1,000 rows of data, and that's what you're using to train the model. So you'll separate maybe 20%, or you'll say 80% of the data is what you'll use to train the model, and then there's validation you use to test now the trained model, because for the validation you already know the results of the 20%, but when you're training you'll now hide the results from the machine learning model and then try test it. It's more like the same way we do in school, where you're taught you're taught something, and then when it comes to the exam, it's maybe you've never seen the concept, but you can apply what you learned and test and get the correct answer on a question that is asked. So this is what we're usually trying to do. And there's also some concepts we're going to look at, like overfitting. So picture if you are going to test it, to train a model with 100%, or 100% of the data, and test it on the same data. The accuracy will definitely be 100%, because it's just checking on things that it's already seen. And like the examples we've given, in future you'll be looking at data that the model has never seen. So this is where you're going to do that. So you'll try test, build the model so that it's able to predict accurately data that it hasn't seen. If you look closely here, there's this blue line here. This is where you will spend, like Timothy had mentioned, now the calibration that happens here. And this is where you might actually, this section here, you might take a week or maybe less, depending on the data. But in this section here is where you should always take most of your work, most of your time. So you'll actually be, so once you now bring in the data that you're going to use to test, then you're going to have several iterations. So there's this concept here we're going to look at. With the regression we're going to look at today is not exactly so complex, but you can actually do, for each model we're going to look at, it usually has several parameters that it takes. So I can give one example here. You can see my screen. So for instance, with so we're going to mainly use scikit-learn for this section, and in each one of these you're going to find so for instance, if maybe it's classification on this decision trees. So for each machine learning model we are going to use, so for instance, this machine learning model is called a regressor. So each one of them usually has all of this here. So these are what we are referring to as the hyperparameters. So each of these has a certain impact, on how the model is going to work. Each of all the machine learning models we're going to look at, you can just come to the documentation. You're going to see what now, like for instance, the first parameter is criterion. So you can look at maybe the description and you'll see what each parameter impacts. And there are those that we're going to maybe change the number of iterations So that's what we are referring to by hyperparameters. Some are maybe just a method and some are numbers. So like you see, minimum split is 2. So that kind of thing. Any question?
On the data sets, there's something they refer to as out of time.
Yes.
Something about it?
So just a minute. Okay. So out of time. Okay. This is by out of time on what context? On the data you have.
Yeah, when you're splitting, when you're testing your model, like
yes.
the credit scoring bit, I'll always give examples with my job banking. Yeah? So the credit model, there's testing your model against some out of time data sets.
Yes.
Yes.
Okay. Maybe how I understand it, it might be something on it might be maybe data that is off, or maybe given certain aspects, it will completely throw the model off if you use it. So maybe when you're now doing the data analysis here and just visualizing, you might see maybe certain aspects that will completely put off the data, or like what Timothy had mentioned with outliers. So you might find something that is very off, and if you use it within your model, it's going to give, you will get a result, but it will be very biased towards a certain side. Yeah, I think that's what that might be referring to. Okay. So yes. So in this section, so this is where, so one of the things you're going to do as you're, so first thing you're going to do is, even maybe what we're going to do today is just use the model as basic as it is, and train the model, and then you get a certain result. When you get a result, we're going to do a validation test. So we'll get a certain score where we're going to now measure on the accuracy of that. So so the question is usually always, have we gotten the best score we could have gotten? So that's where the parameter tuning comes in. And there is a number of methods we can use. They get quite interesting. What is usually happening in the background is quite interesting. It's a lot, and sometimes you might not see how much. The other maybe concept, the other thing I've seen with these machine learning models is like when you're doing this part here, we only just write the model and then .fit. So it can be a bit anticlimactic because you expected so much to happen, but yeah, but basically there's a lot happening in the background. Like I mentioned earlier, the math is there, but it's just been simplified for us into a library that you just call and it does everything for you. So this section, depending also on what you're doing, it might take a lot of processing power. So there are instances where we are now going to, like I've seen you've been using Kaggle. So there are instances where if you do this on your computer, it's going to take too long. So you will just maybe change to a cloud platform that probably has more resources or more processing power to help you with your work. So this is where we're going to do a lot of work, especially like when you're doing classification. We'll do a lot of this, and I'll give you some exercises for you to try and get the best score. So we'll have everyone doing an example and try and get the best score. Try and see if you can get the best score. And if you think of it, this is actually where Kaggle comes in, or Zindi. So in those platforms, this is where now like the true or the best data scientists are seen. How you do the hyperparameter tuning, how you select your model. Sometimes also it might be you're working on a model that will never get a better score. So you might do this and also change the model and then come back here. So you have to do so many of these until you get the best score possible. There's this, have you seen something called deepfakes? Deepfakes, anyone? So it's a result of machine learning. Yes.
Oh yeah, I was saying we had seen some deepfakes with like Obama speaking, or
Yes,
rather
yes.
simulation of Obama speaking, but he's not quite the one speaking.
Yes, yes. So there's a lot of that coming up these days, and it's a result of machine learning. Maybe a bit deeper into machine learning concepts, but I think sometime in February there was a competition on Kaggle, and the prize was $1 million. So the challenge was like how like you design a model that will be able to identify a deep fake. And can you imagine that was being paid for $1 million? Whoever will win will actually come up, will actually get the prize. So, and yeah, I think someone, and most of the articles these days, even if you've noticed, some of the videos on YouTube are actually not made by a human being. They are all more like generated by machine learning algorithms. So you combine articles and put them up. So you'll see those videos, they have pictures that are kind of not related to what they're talking about. So those are just a few examples there. There is, I'll share a video as well. I'd shared sometime I think in January, there was a competition on coronavirus, and it was more on, from a pharmaceutical point of view. So within machine learning, there are libraries for pharmaceutical application. So in those models, you're actually able to describe a virus based on maybe its DNA and now the medicine that's available, and it's able to search through the different medicine that are available or that can be made and that to fight that virus. So the one that they just announced this week, in that competition, the one who won actually had that medicine as the possible best medicine to fight coronavirus. So you can imagine like that medicine is now actually a result of someone who implemented data science. So this here, and there is, within that video, you're going to see this being done a lot. And so for them, they do a lot of this, and they finally end up with a model that now actually predicts that this is the best medicine to use. So that. The other section we have to talk about is on validation testing. So once you've selected the model, so validation testing, there are various methods that are used. So I think like the guys in banking and those with a statistical background, you've met this a lot. So for instance, so one of the easiest ones, like with the linear regression, we're going to use root mean square error. So this one just checks maybe how off, maybe like we're going to do one here. So for root mean square, it's just going to, as you're generating the model, it's going to look at where the line is drawn and actually maybe just check on the error. So the error will be based on the actual points versus where the line is drawn, and then so it's map position versus where it is, and you can see the model iterating here. So it will check where it is, and it will slowly, as it iterates, it will make sure that it's getting the line with the least amount of error. So checking from the distance from one point to the line, you square it over all total number of errors, and then you get the sum. So that will give you the error. So that's one of the simplest methods. Then there is cross-validation. So very much like you were saying here, cross-validation usually will use, when you split the data in this section, you split the data into this section, so you'll have 80% being used to test to build the model, and 20% for.
So, James,
yes.
When you're doing this work, what tools will you be using for that? Will we just be using purely Python? And the reason I'm asking this is because I have used Azure to do a little bit of machine learning, and we were using, it's a graphical user interface. So where you simply just drop, you drop your data set, you create you have the arrows to show, to do the splitting and everything. So in this case, what tools will we use? Will you use purely Python, or there are special tools that we shall use, maybe graphical user interface for the learning?
So in this section, we're going to use purely Python. So I can give you an example here. We're going to use Python, and it was maybe what I've seen with the other platforms is they assume a lot, or they do a lot in the background that they don't show to the user. Like I mentioned before, they are trying to sell to everyone. So maybe not everyone is tech savvy as you guys here. So for guys who are not very much into tech and understand all the programming, then they're going to do a lot in the background and you'll not see that. So for instance, just maybe going through one of these, just for you to see what's happening. So this is the section I'm referring to here right now. So you'll just start in this section where you'll, so there's this function, there's this library here for model selection, and then there's this test string function that we use. So with this, you now get the, for instance, here we said test size is 0.4. So this is like 40% of the data. Then you can also randomize, so not necessarily the first 40%. It's just randomly within the data, take 40% from that, and then yeah. So I've been able to answer your question, right?
Yes. So purely we'll be using Python. That's the clarification I want.
But now the interesting thing, we'll use Python and we'll use scikit-learn. So what you will find is when you learn these concepts here, and you now move to maybe Azure, or you're moving to for instance TensorFlow, basically the idea is the same. You will see that they follow the same procedure, only that now the libraries are different, or the functions are different, but you still implement them exactly the same way. And like here I'd mentioned, like now when you're doing the model fitting, when you're training the model, it's usually very anticlimactic because this is all you write. For some, it will, like when it's not very complex, you just write once, do the fitting, and you do the fitting, and that's it. Nothing much more to add. But for some, it takes a lot of time to fit the model. Okay. So maybe so for today's session, I wanted to just everyone to have a good understanding of the whole process, because the next classes we're going to be starting straight into the into coding. So but in the background, have in mind that this is what will be happening. So you'll be going basically through this same process, and also some instances you change. So for cross-validation, I hope you've understood. So it's basically comparing, once you split, so you compare versus the, you compare now the trained model, if it will be able to guess right values that you already know. And from that, you'll now see how accurate that is. There is also these other concepts here, like confidence interval, confusion matrix. I think some of you have met these concepts, especially like this. for receiver operating characteristics. This is used heavily in banking for selections of models. So once you come up with some models, so we'll look at some of them when we are coding, and some of them we look at them as we are coding. Maybe they'll be best understood then. So the other concept here in machine learning, or when you're doing validation testing, is so like in cross validation, there's this one here that you'll come up with. This is usually called a confusion matrix. So for confusion matrix, I think the way, so you'll end up, so there's the actual figures and then there's the predicted figures. So if the machine learning model is able to predict the actual figure correctly, we call this a true positive. If it says that a certain if it's not able to guess a correct figure correctly, then we call it a false negative. And then the opposite is the same. Like if it says a certain number is positive and yet it's not, then this is a false positive. And then there is also saying that a negative number is negative, and that's true negative. This usually a bit confusing. Have you guys understood it?
Are you looking at the numbers in the true positive or true negatives, or how will you be able to validate? What will
So this one is usually like, so for instance, like the one, so like picture in this section here, you had 80% going into training and 20% going into validation. So, so now once you test the model, once you've trained the model, you're now going to tests. So when you're testing, you will now come up with this graph here. So out of maybe 100 of them that it was testing, it was able to correctly flag 80% of them, 80 out of 100, that these 80 out of 100 they were labeled correctly, and so these are true positives. And then at the same time,
so are they in terms of percentages or numbers or?
Yes, so now they'll actually be in terms of percentage, because now you'll be looking at it versus total number.
And what percentage would you say is good for each of the boxes?
Yeah. So there you'll be. So what the final number that you have here is more of a percentage. So it's more of 80 out of now the total. Okay, yeah, it's now 80 and versus the total number of all the values that were being tested. Yeah. And then now maybe like for negative, these were not correct, and then you actually guessed they were not, maybe what it got wrong. Like it's more of like, picture this as a teacher marking the results of a student. So they'll be able to get some answers correct and some they'll be wrong. One of the brilliant ways I've seen how to understand this is if you have two people who've gone to hospital, one is a man and another one is a woman, and the doctor says the man is pregnant. So if the doctor says the man is pregnant, this will be false. And so now the doctor is the model that is predicting, and if they say the man is pregnant, then this is a false positive. If it's the woman and they say the woman is not pregnant, this is a true negative. Or yeah, so that's maybe the best way, one of the best ways I see it.
Yes, I understand that bit, but yes, my question is the thresholds, so that you can see now, fine, this is a good one.
Yes. So the thresholds are based now on the model you are using. So the model, and maybe it could have been so this, it could have been a classification model, or it could have been maybe a regression. So it's purely based on maybe how well it was able to label correctly. So if it was,
James, maybe you can tell him about the p-value. I think that measures the threshold well.
Oh yes. Oh, there is that. Maybe when it's now in terms of figures, that's where maybe for labeling, it will be more of just labeling the correct name. But for when it's more of figures, that's where the p-value will come in. And maybe if a value is maybe now within the fifth percentile, the first or the last, so you'll know how correct or wrong the figure is. Okay. So the other aspects we'll see when you're doing validation testing is these other measurements that are within, these other measurements that are generated from confusion matrix. So one is sensitivity, there is specificity, accuracy, precision. So all of this, they have certain weights to them, and they're used in various you'll see maybe some tendency towards maybe like this specificity and sensitivity. For accuracy, it's usually more just comparing like this true positive plus the true negative of now the total of it. So you'll just end up with a score out of 100. And then for this as well, this will be now out of 1. So what we'll do is we'll end up with these graphs here. So we'll do now what I was talking about in this section here, the receiver operating curve. So the receiver operating curves, we get them by doing sensitivity over specificity graph, and this is more of 1 over 1 minus the specificity value that you're going to get. So the graph usually ends up as it's more of a perpendicular line, and it's more correct depending on how closer it edges to this other side, to this corner. So when you're doing the test, or when you run these models, the closer it is to this edge, the more accurate it is. So for instance, and then for also in this section, we're going to, there's also an area, they call it AUC. So AUC is checking is usually just area under the curve. So if you probably have several models and you have like, you've run them and you end up drawing the sensitivity, the ROC curve, then you'll end up with maybe like these 2 lines here. And the question is usually, how do I choose which one is better? So with AUC, you'll actually, with the area under curve, when you calculate the area under this curve and area under this curve, you'll actually see which one has the higher score, and that's probably what you should go for. Any question? Any question? No. Okay. So I think with those concepts, then I think we can now get into the coding section of it. We'll look at 2 different concepts. They are pretty straightforward, or yeah, I'd consider them straightforward compared to the other models we'll look at in future. So there's one called, so with linear regression is what we've done, sorry, I think I'd say from all the way from high school. It's just maybe like a concept that has only one dependent it's more of like this. So we have like a simple regression. So simple regression is a concept like this, where there's one dependent and another. So this is what you're trying to predict, and there's only one variable that is changing. So like said, there is like from, I think from high school, you remember this is now the intercepts, the y intercepts, and then x will be now the variable that is changing, and when it changes, what ends up. So some of the data we are going to analyze, you'll see you'll have, the question is you're trying to predict the next values here. So with linear regression, if the relationship is just very basic, like it's very almost has a very high correlation, you could just use a linear regression model, and it will end up with it will run the function will now end up with a straight line, and you will be able to maybe give just the value of, given a value of x, you will be able to now predict the next value. Then there is so we look at these two aspects. So there is linear regression, and then there is logistic regression. So also maybe just to mention, with linear regression, this is the relationship for some of the simple concepts that are there. But you know, there are those that are, you might find a value that is dependent on two values. So we have simple linear regression, there is multiple linear regression, and then there is polynomial, where you now maybe have a line that is more of a curve than a straight line. So all of these things, functions for working those out, and we'll see them. For logistic regression is usually, first, the simplest one is on binary logistics. So you're more like comparing just, or the data can be classified into two different classes. So they are figures, but they'll just be divided into two classes. So that's where binary logistics come in. So I kind of try to think of logistic regression as a knob. So there is, you see, with linear regression, the value can be, with given the x can be something, and the value will be, y can be a float. So it can be any value. But with logistic regression, is given x, the value is always a specific thing. So it's either this or this or this or this. So with binary, there are only two results. It's either this, it's a yes or a no. So for instance, there is one example we can use on, there's a data set that checks on types of cancer. So there are two types, so you'll, based on the data you have, you'll end up with only two results. So that's a very simple one to use, and you'll see that. But also you can end up with maybe three of them. So there might be one here, and another one here, and another result here. So there is what is called multinomial logistic regression, when you have three outputs. Then there is ordinal logistic regression, where maybe you have 4, 6, 5, that kind of the final result. But basically, with logistic regression is there's defined outputs. The outputs will always be specific. So 2, 3, or more. Yeah. Any question? Yes. None. So I'll share some. I'll share
just a question, James. Is there a particular data set we'll be using? Maybe you can share it with us, and so at least we also familiarize ourselves with it.
Yes, that's exactly what I was going to do next. So
okay.
Okay. So there is this. I'll share a folder here. So just check on the chat. I'm sharing a folder with you. It's on Drive. Some might have already been shared with you. Okay.
Kim, you can also email them to Alice. Then she will share to the class via email.
Okay.
Yeah, together with the presentation, so that.
Okay.
Together.
So, Alice, it's the same link we've been using for the others, for the other classes.
Yeah, exactly. Yeah.
The one for the forecasting?
Yes, now within that folder, there is a folder for now machine learning, just for the intro.
Machine learning?
Yes.
Okay, I'll check it out.
Okay. So, get shareable. Anyone with a question? As I upload this. So I've just sent it. So it's open. So just have a look at it. So those are, you'll see some of the some models that we more like I'd say there are some notebooks that are already prepared, but we'll go through. We'll create one right now that we'll test these concepts. Okay. So just try everyone to now open their notebooks. That's Anaconda. Everyone has Anaconda installed, or you can use Kaggle as well. Has everyone been able to access the data? Mm-hmm. So please, so just change to this.
Which folder are we using?
So just check first linear regression.
Okay.
We go to linear regression, and so basically what we'll use in that section is we'll use the data we're going to use. So just check and okay. So let me just combine this. So within this folder, you're going to find this machine learning. Yes, so you'll find these three folders. So the PPT we've been using, this is it. And then, so we'll use this folder here. So just download it and put it on your machines. So the data set we're going to use is US housing. So very much like you've been doing with the other data sets, we'll just follow the same procedure. So yeah, so we'll just follow that as well. So maybe when after this class, you can just go analyze this, maybe just to get a good understanding of what's happening with the data, what's happening with that data. So create this folder. So I'll just create it, regression. So first thing, as we've always, I think you've done in the previous classes, is the default libraries we've been using. So just use them here. So we import them as normal. Matplotlib. And there's this other one. So CNS, which one have you been using for visualization? Matplotlib or Seaborn? Yes.
Both.
Yeah, both of them.
Both.
We have been using both.
Okay,
I don't know
so
which one is the best to use, or we can maybe stick to one.
Okay, I think
Plotly.
yes. Okay, so someone has said Plotly. I challenge them to have a look at Bokeh as well. But anyway, the bottom line is there's a lot of visualizations, and they give you different features and capabilities depending on what you're trying to do. So like Plotly, someone has mentioned Plotly. It's usually really good for when you want to have an interactive graph. So like you might be analyzing data that is over 20 years, and there's so many data points within 1 year. So you see, like if you use Matplotlib, everything will be clumped up together. But with Plotly, you'll actually be able to zoom in into a specific field. With Matplotlib, you can still be able to do that, but with some more coding. But with Plotly, it just makes it a bit easier. So you can try them. Seaborn as well looks a bit better than Matplotlib, but yeah, it's all eventually depending on what you're trying to display and how much of it. So yeah, so the level of control that you want to give to whoever you're going to present it to. Matplotlib is really nice. Plotly is really nice, especially if you're going to put it on a website or an app. So there's also one called highlights charts. Have you interacted with this one? Anyone? But this is based on Java. And Plotly kind of looks similar. So like what I was talking about is here. So like when you'll have a graph that looks like this, and you can zoom into a section, or you can now select data. Depending on if it's maybe like a time series like this one here, you'll actually even be able to zoom. So like what I was mentioning, if you are analyzing all this data, maybe you want to have a closer look at a specific year. So you can actually zoom in and look at 2013 alone, and now this looks much better. Or even if it's a certain week, and you'll see the exact data points. So yeah, you see, this is a better visualization than the static ones you get with Matplotlib. So it's just purely based on what you are doing. So yeah, so we can just we can create now the data frame. So importing of the data we're using. So just pandas, then read. So this is if you have trouble sometimes getting this section here, or maybe struggling with the correct maybe spelling of the name. When you get to this section, instead of trying to guess the name, just click on tab, and it will show you all the files within that folder, and it's much easier to do that. So do that and then just run. So next thing, it's just maybe to just explore what's happening with this data. So this section, maybe the data we're going to work with is more of it's already clean, but it doesn't hurt to just maybe just exploit. You had already done all of this in the previous section, I assume, right? Yes. Harriet, you have a question?
No, I was going to say yes.
Okay, thank you. So yeah, so it's just basically, so first thing is maybe just explore the data, see what's happening, how many columns are we having. So always try to do this with the data you're looking at. So just explore and see if maybe there's a problem, or if there is a need for you to actually clean it up. So yeah, then maybe just one last one, you can just plot them out. We can also try to do a correlation plot, because now maybe for today we're doing linear regression, so correlation would be perfect to have analyzed. Maybe that's
James.
Yes.
Maybe you can take a pause. They each share the screens so that we see that they've
okay.
launched the terminal for Jupyter.
Okay. So please do. Just share. If you are stuck, just mention if you are not able to import the data as well.
Okay, for me, I downloaded the notes which were there in the drive, so I'm just going line by line.
Okay. Preferably if we can just open a new one.
Okay.
I haven't managed to download.
Yeah. So normally, okay, when we in class, we usually go through. We'll write this, and everyone will be writing the code in class. When we are with the Zoom setup, sometimes it's a bit of a challenge, but so that's why I think Timothy is trying to follow up to make sure everyone is following.
Please take me through the downloading.
Okay. So let me just share my screen.
Lina, she can share her screen instead?
Oh yeah.
From email, as in I'm at that point I am trying to open them, and I'm not able to import.
Oh, also my assumption is everyone is on Gmail, but so just make sure you're logged in on your Gmail, and then just open the folder. So please share your screen.
Which one now? For my Gmail?
Yes, yeah. The folder, the link I've shared.
Lina, you can share your screen so that you see where you're stuck.
I'm even trying to get the. I just share the screen, yeah?
Yes. So you downloaded the folder?
Now I'm trying to go back to my screen.
Okay.
I'd copied it and opened it. I was able to access them, but I was trying now to download them so that I'm able to open.
Once you download, then you need, when you're opening, you open them through the Jupyter notebook.
But I need to first save them on my desktop, no?
No, okay, no, you don't need to.
Oh, okay.
Just open your Jupyter notebook. So you had downloaded it, yeah?
If I remember, yeah.
So you can click on downloads. You can still find it there.
No, where's my screen? I'm only seeing the
You see this, whatever is showing right now.
The
okay, you
control.
can remove the black, minimize it. So where it's written homepage, select. You're seeing downloads.
Where?
Downloads on the files. There's 3D objects and a
Oh,
contact.
yeah, yeah.
So are you able to see the folder that you downloaded just now?
No, I don't think it had downloaded.
So it hasn't downloaded. So just go back to your email, then download, and then you'll find it here when you download it.
Yeah. Anyone else? Everyone else okay? Everyone else is okay and ready? Please respond.
Yes.
Okay.
Okay, so we can proceed.
We can proceed, but then Lina, you can just show us once you finish. Just raise up your hand, then you can share your screen.
Yeah.
Okay. So I was trying to maybe just show maybe as okay, let me share. Okay, so I was just trying to do more like we can just do it's more like a scatter matrix. So you can do this with Seaborn, or you can just do it with pandas. So with Seaborn,
question. Yeah.
Yes.
Sorry, your data, is it just open? Just do your DF. Your head. The data file head receive. It's the same as what you have.
Yes, and then it's this one US housing.csv. So that's the data you have.
Okay, yeah, it's the same. Yeah, it's the same.
Okay. So also, as you maybe this is still just trying to have a look at what's happening with the data. So maybe with Seaborn, we can try a pair plot. They call them pair plot. Then we just give it the DF. So with this, it will give you more like a quick visualization of what's happening with the whole data. Yeah, so it's a bit big, but make sure. Okay, as maybe that is doing, we can also write one for. So if you do that, you're going to, yeah, maybe sometimes it's a bit hard to. You'll see where there is a relationship, where there is none. You'll also maybe see the distribution of all the data within that. So this, it's usually just to give you an overview of what's happening. So with this, you're able to see what's happening with all the data. So like in the exercise you are doing in the previous class, it's nice to maybe just use this to know which one to narrow down to, like what analysis to narrow down to if you are maybe not sure which one to go with. Lina, you okay?
Yeah, it has downloaded.
Okay. Okay. So,
just a question, James.
Yes.
I realized yesterday when I was trying to make the graphs that it can take a lot of time in terms of processing power.
Yeah.
I don't know what alternatives would you advise we have, because what you're doing right now, we are running whatever we are doing on our local, local laptops or PCs. So it might take time, maybe because we don't have enough compute to probably process a lot of data. But what would you recommend for us to use so that maybe we want to use the power of the cloud to make it more efficient?
So one of the brilliant tools are there. So I think you are using Kaggle, right? So there's Kaggle, and then there's something called Google Colab. Have you heard about this one?
No.
So Google Colab is, let's say just that Google has a lot of computing power, and maybe they use it all the time, or they have something they can actually share, or so this basically, this is the same as Jupyter. The same as Jupyter, but now it's based on the cloud. So when you're dealing with when you're doing a lot of, especially like right now, maybe what we're going to do in most of these classes is not very heavy. Lena, please mute. Lena, you can mute your mic, please.
Oh, sorry.
Okay, so I was saying, so this is basically the same as, it's the same as Jupyter. So you can actually use it to, if you find maybe your computer struggling a bit or taking longer than usual to do a certain operation. And then the other good thing with Google Colab, it has everything installed. Like you don't have to start doing the installations. Like though Anaconda does most of the library installations for you, but you'll have with the Google Colab, everything is present, is already pre-installed. And the good thing, even when you now start maybe doing some of the if you're now doing a bit of deep learning, like now maybe using TensorFlow and Keras, so you'll find everything already installed for you. So, and they are pretty like there's a function for checking the processing time. You can actually try it on Google Colab and then run the same thing on your computer, and you'll see this one is usually slightly faster. And especially when you're doing like what we're doing is maybe this was 50,000 lines. This was just 5,000 lines. So you can imagine there are times when you're dealing with 1 million lines. So Google Colab is a good alternative. There's a lot of them coming up these days, but yeah, Colab, Kaggle, yeah, all of those you can use. So basically, okay, something about this syntax. Use a capital X, but okay, but this will basically plot the same as what we are looking at. So maybe the other thing we can do is do a correlation. So especially now, like for linear regression, correlation is very like it will already tell you if you need to go for something. So it will already tell you if you need to go for a certain option or not. So like if you'll see a straight line, especially when you have very many columns, you will see which one are related. So this is one way of showing it, but you could also just maybe just now with so like I think from the statistics you have, maybe like checking on correlation, the higher number is closer to 1, the more correlated it is, or the lower, the closer it is to 0, then it's probably not even related at all. So also the other thing is correlation is usually symmetrical. Yeah, so it's usually symmetrical. So what you're seeing on this, so there's this 1, 1, 1 here. This is mirrored on the lower side, so you can just ignore the one part and just look at the lower part here. So like this one here, the correlation between average income and price. So like I'd probably try this on the data you are analyzing. It might show some interesting, might show some interesting info. So we can just do this and we give it just that. We give it the same, this, we can try maybe visualize this a bit better, especially like when you have very many columns. If you do this, if you're trying to look at numbers, they might be too many. So a graph is always better. Yeah, so like this, and with this Seaborn, it will now maybe like even try and annotate it so we can ignore everything that is black because there is absolutely no relationship. And then there is what is closer to 1. I think the best one we've seen is this 0.64. So maybe it will vary depending on the kind of data we have. So there's some data that will be probably more related. So for instance, with linear regression, we can try and see if we can use this to price and average income.
Let me see what we imported the libraries, because I don't know, my correlation function is not
okay, just check on this. So there's Seaborn, NumPy.
Matplotlib and
yes, Matplotlib and NumPy. Yeah.
I don't know. My correlation function is not doing anything.
And the Python is case sensitive. This is okay. Or you can also try maybe there might be a problem, or check the number of brackets or correlation.
Actually, even the above, before even that, the statistics above there about that one.
This one also.
It is CORR. I mean CORR.
Yes. Yes. So maybe we can do this.
Not sure what
okay.
You can share your screen.
Yes. Also, the other part of coding is debugging. This is probably one of the things you're going to do a lot. Coding is just one part of it. So yeah. And you need to be able to be quick. So please share your screen.
Is it shared?
Yes. Run.
This is what I'm trying to run here.
Nothing.
No, before the heat map, these are the.
I don't know why, because it's not even running.
Yeah, that's.
Oh, just go back to it.
Yeah.
Just check where you have next to the no on the under the menu bar. Just not scroll. Just take the pointer up.
This one.
You just take your pointer to this where there's a keyboard icon.
This one.
Yes. So the next to it, there's a drop down. Yes. And then choose code. Yeah. It wasn't running. So just run it.
Nice. Thank you.
So also like maybe okay.
Just for me.
Yes.
On the heat map, it's not very clear. Some values are overlapping. I can't actually see them.
Okay, with seaborn, I think we can change the size. I think it's figure size or something. Fig. Oh, okay. So also, so with the seaborn or seaborn. So it's usually, these libraries are a lot. You'll not cram everything. So it's always good to just use the reference. All of these usually have very good documentation. So you can always come back to this and maybe just check on a specific one. They'll always have their code here, but so like for instance here, we want to just change the size of the graph. So for
it's fig size. But
they confuse me sometimes with size. So maybe
let me see if it will work.
Okay.
No, it gave an error. So.
Yeah, I wasn't so sure. It's fixed size because there's fixed size for. There's the one for Matplotlib. So the easiest way is usually just come to Seaborn or just check on, especially when it's not a new concept, just plot size. So just check on it. It will always, you might take 30 minutes trying to figure something out, and yeah, it should be Seaborn. Yeah. So I think you can just do that, should be. And then the other thing is also, every time when you have a bug, when the code doesn't run, Python will always try to point to you. Was the first section, it will point to where the problem is. So if it didn't run, where was the problem? So you see, it already points to you where the problem is. And then the other section is pointing to the libraries, so where the program failed. So, and also now when you come to the last section, it will tell you maybe where exactly the problem is. So that is, oh, okay, just do this. I think fixed size is for plots. And move that there. But I think maybe we'll not concentrate so much on these aspects because this was in data visualization. So we'll look more into these other aspects than the other one. Then we'll ignore some of the visualizations and then concentrate more on the machine learning part. But we'll use some visualizations, especially where we want just to see what's happening. Like I told you, some of the machine learning models are very anticlimactic. You just write fit and that's it. So we can use a we can use a chart to maybe visualize what's happening. Also, as the program is iterating, you are able to actually see maybe what's happening in the background. So So, but anyway, so you can just do this, define the figure size and then make it a bit bigger. You can probably make it this 10, then it will be a bit bigger. Okay. Okay.
It's still having the same effect. Like the first row is it's like hidden. You can't actually see anything that is inside it.
Oh, okay, please share your screen. But yeah, so like I mentioned, debugging is sometimes 40% of the job when you're programming. You do a lot of it.
I don't know if you can see. So you can see this area, average income. I can't see anything above that.
Okay, to try this, take that line, the figure size, take it above the enter. There's they call it the programs are usually sequential, so it runs. Oh, that's weird. It's still there.
Yeah, it makes it big, but still it's still not.
I don't know why.
Or maybe I might have to restart my.
Sometimes, okay, restarting solves the problem, but you didn't. In manufacturing, we say that sometimes you do that and it solves the problem, but you don't know what the problem was. So maybe we will try. You didn't get to the root of the problem, but maybe we can try. We'll try maybe just. Maybe for now, maybe we can just skip it, and then I'll try look at it, and then we'll see what's wrong.
Okay, sure.
And then did you also?
So this one worked. The rest worked okay. The correlation works okay.
Okay.
And
there's check on the libraries that you imported at the very top. Just scroll up there.
So I have.
Or you continued on a different.
Yeah, yes, went on. Yeah, but I have. Maybe I can just copy them and.
There's this line. It's usually called. Just a minute. Yes, so you got that, okay?
Well, let me try and see if it will make a difference.
So there's this function that is used. I think you had done it on mine. Eh? So just scroll down. They call it a magic function.
Okay.
So, just before the plot.
Okay. Here.
Before that, enter, okay. Then ampersand, like percentage. Matplotlib. Okay. Yes. Matplotlib in line.
One word.
Matplotlib, and then no space inline. Yes, run. Okay, maybe let's just I'll check and. Okay. All right. I'll check and give you the solution enough here.
Okay.
Okay. So. Okay. So back to our section. Let me share my screen. Yeah. So everyone can see my screen. So we were looking at this. So when you have that, now you can more like figure out which one. Instead of doing all of them, you can figure out where to narrow down on. So okay, so maybe the other thing we'll do is just check the columns we have. So is that so these are all the columns we have, and so now since we've seen price is the one that kind of has a higher correlation compared to any other of the values, so we'll concentrate on price. So we can have the data, we split it into like two sections. So one, we're going to use it as it's more like we said in linear regression, it's y is equals to mx plus c, right? So you combine, you're trying to predict the final value based on certain, based on one value. So one value, or it can even be multiple. So we can even start maybe by just using average housing. So this can be, so you can just try, we base this on just the average housing alone. So all, like I mentioned as well, you'll get into some trouble if you try to guess, to write the name correct. So the best way is usually like once you just put this, what are they called? Once you put those marks there, you write the first letter and press tab. When you press tab, it's going to bring all like now for this instance here, it will bring all the columns within the DF. So you'll not get some bugs that you did not import correctly a certain column. So because if you get the spelling wrong there, then nothing will work. So there's that, and then we can give y the price. So that. So x and y. So you see in all the machine learning models will try have different variables, and mostly they'll be now the two variables. So there is one that we are trying to predict, and then there is the dependables. I can consider them maybe as dependables. This we can try just maybe for now we work with one and see.
James, a question, yeah.
Yes.
If I use df the data frame dot index,
yes,
it gives me some value, like it says start 0, stop 5,000, and then step 1. What does that mean?
Okay. Index. Oh, index. This index is usually so okay. Let me just display df.
Okay.
So index is this. This is the index, and sometimes you can set the index, so you can decide that this is your index. Like there are sometimes or the instances where you'll already have a numbered column within your data frame, right? Okay. So you can set, because the way Python will work, it will give us the index if you haven't set it. So that's a work of index. So you can set it sometimes, or you can just if you don't need it, then you can just leave it out. You'll see like in the next section, when we're doing forecasting, you'll see this one is very important. You have to set the index correctly. If you don't, like the index in forecasting is usually the date, and if you don't set it, nothing works. But maybe for this section is just for numbering. So yeah.
Okay.
That's okay.
And if you use df dot values, I saw it also gives you some values.
Mm-hmm.
What essence does it have to have it?
This one will give you the values, all the values in all the different columns without any order. It just has one matrix, and I think it's like, yeah. So this gives you the whole. Then you can also try this. Okay. So okay, values gives you all the raw values in all columns without any order.
Okay.
Yeah. So like if you look here, you'll see this like we have Johnson views. Everything is basically just combined into one thing. So, but I'm seeing it's so it's probably set everything into an array, but it's like it's a multi-dimensional array, but now without any order. It's probably better if you want to see. I think that's where now using head is usually better. Like yeah. Yeah, at least when you use this, when you're trying to see the matrix this way, it's more organized, and yeah, you will see the whole structure.
Okay. Cool.
Okay. So now back to machine learning. So here, so once you've created the X and the Y, all machine, remember like what I said is now we do the splitting. So the first thing is doing splitting, where you want to see, you want to create two variables. Huh? You want to create two, like two sets. One that you're going to use for, modeling, and then the other one you're going to use for testing. So what we use for that is sklearn, and this you will see we use for all, using all of the, basically all machine learning models. We will use this. So yeah, so you'll probably, like when you're starting any exercise in machine learning, just know we're going to use this one. So just import it. Okay. So it's usually called train tests. So this one is what we're going, it has a function inbuilt that will help you to do all of that. Then once you do that, then it does, you'll now call this X test. So what I'm creating here is, see, this is X train X test. So there's one that I'll use for training and another one that I'll use for testing. And then you do the same thing with Y. And it's an underscore. Okay. So then you now call the one that we've imported, and then now you'll give it X, which is what we've done here. So this can be multiple columns or it can be one. Then we give it the dependent Y. Now the value to predict, or for now we are still testing. Then so if you
the command, sorry, excuse, the command line that you give an error. I don't know if everyone is having this. Is okay.
So maybe just Google this. So under sklearn, you're going to find this. So it's this it's a function that we use to split. So make sure you have the, like I said, Python is case sensitive, so be careful with the case. So under here you will see what each of what we are going to use. So depending on which model we are doing, you will see there some will use this random state, some will not. Test size, you'll see will define these figures here. So maybe just in case, maybe there might be a letter that has that was off. Try copy this and copy this and paste it. It should work.
Okay, cool.
Okay, and then now see, still this is now the next thing we are doing. So X train X test. So that, and then now test size. So yeah, test size. So we're going to, so this one here, this is one of the components you can actually use to tune your model, sometimes you might use a very low value and maybe you test with 10% of the data and the score is very bad or good. So it's one of the things you can try and play with around with when you're tuning. So test size. So this here, remember, we're getting this from this. So there are certain aspects you have to always give. So like this test size. Okay, just a minute. Just a minute. So this can be between 0.9 and 0.1. So just try 0. So we'll try and see. So 0.2. Yeah. Then there is also an option for random state. So that one also is maybe we can try use that. We can just maybe first test it this way and see. Random state usually is it's trying to randomize how it picks the numbers within the distribution. If you, for instance, split the data and maybe it's a time series data and you do 0.2, so it picks maybe the first 20% and ignores the rest, and you see the data is sequential. So what will happen is you'll end up with you'll end up with maybe you'll end up testing on you'll end up training the model without it visualizing the whole. You'll not see the whole data or the whole size of the data. So it only analyzes part of it instead of the whole of it. So it's always better to randomize, so it will pick distributed from the start to the finish. So that's where now this random state comes in. Random state, which yes, no one. So I sometimes when I'm training, I kind of you can try different values, and when you try different values here, I use the term that the computer will not explode. So experiment as much as possible so that you have a good understanding of what's happening with all of this. So yeah. So, yes. Yes, Mercy.
How about if you want to have the same number of numbers even when you run the code or when you do the modeling several times? I know for R you use set seed. What do you use for Python?
So sorry, when I want to have the
same number, like I don't want, when I'm splitting the data, I don't want to have different random numbers anytime I have to run the model.
Yes. Oh.
So I want specific numbers. So I know R uses set seed, so you have the same numbers. The random numbers are the same. You don't have different random numbers when you run. So what do you use for Python?
Okay, so maybe we can just go back to the documentation. I think so this yeah, okay, there's this shuffling, and then okay, I know that option is usually there sometimes for some different models. Okay, oh,
Python
this
you use
yes.
In Python you use seed. There's a function called seed. Then you put a number inside as a parameter.
Yes.
Every time you run a random generator, to always generate a random number of the same kind. Yeah.
Okay. Yeah, because now like this one, if we do that, we'll actually have everyone will have different values. or the score, if we are now, because everyone will be doing that on different set of random numbers. Yeah. So the next thing after that is sklearn. So we need to import now the linear regression model. So same thing. So regression. Yeah. So that, and so here you can give it any name. So this is just a variable, and then you call the linear regression model that you imported. Yes.
Question, yeah.
Yes.
Just like we are doing for the pandas and the matplotlib, is there a way we just import the entire library as opposed to the subcomponents within it?
I think, okay, let me, but yeah, probably no. These are components within it.
Yeah.
Okay, I've never tried that, but it should. I think linear model. You can, like you're saying, importing sklearn, the whole of sklearn.
Yeah, just like we do import pandas and or import numpy or seaborn. We
Okay,
just
maybe
import the entire library.
We can actually test that and see. So probably. Okay, maybe the problem I'd see from that is now, like when you're compiling, your program will be big, and it will be very big because now it compiles the whole. It compiles the whole from sklearn. No, you have to specify a different. Yeah, you have to. It's like you have to specify a specific. So these are all the models you within sklearn. All the other libraries within sklearn, you have to specify one. Yeah. Okay.
Okay.
You have to specify a model. Probably, yeah. You have to specify a certain library. Okay, so like I mentioned, this is now where you'll now just give your, you can now, you probably will do several models if possible, but now in this section, you'll just give a certain variable to hold now the model, and then now fit. So when you fit, you now use, you remember we did the splitting. So you'll now just fit with the, ones you selected to test, to train with. Not actually, no? Oh.
And they're case sensitive, eh?
Yes, they're also case sensitive. So it's always interesting when you get an error, reshape your expected 2D array got 1D array. So like I said here, you'll always, this is part of, like, the debugging is always part of the whole. And I think I saw in a different forum, it's still here, like they call it the easiest way when you get in trouble is this forum that we use for code. So whenever you get in trouble, just go there and just check the problem. So like this here, the one we're getting right now is just the way we've set up the array. So this here is it expects a 2D array, but I'm not seeing why. Because this is already an array. It's a 2D array. Can someone see where the issue is? Anyone? So, okay. I don't know what's happening there. Train, fit, train. But anyway, maybe just considering the time for each. Yes?
There's a bit of code there I didn't figure out what we were trying to do. The X train, X test, Y train, Y test.
Yes.
Then we only initialized Y test. The rest.
Which one?
How?
This one here.
Yes.
So this one here is for splitting. That's one we had opened in this section. So it's used for splitting the array or matrices. Like you remember we had said in the presentation. Eh?
Yeah, it's true. I understand that, but my point is, only
Yes.
Y test has been given a value.
Y test. Sorry. Oh, sorry, I'm not getting your question.
See, you have X train, comma X test, comma Y train. Then Y test is what we is what we gave a value. Or maybe yes. These are have they X train and X test, have they been allocated a value?
Oh, this here.
Yes.
This here or this function here.
Yes.
It's going to take now these two. So this is X and this is Y. So it's now going to test. It's now going to take and split them into 80% and 20%, both of them as a 2D array. Then it's going to have 80% of the X will be put here and 20% will be put here. Yes.
Okay.
Understood.
Yes.
Yes, that's what you are doing, like with this, with the test size. Okay. Maybe okay, I don't know. Let me try add a different column here. Yes. Oh, average population. Oh, I think I've gotten out the issues. But also, as we're going through this, there is now a completely built this up in a different. The models we've sent, we've already the folder I've shared has already a built-up model of this. So basically, so here it is. So maybe let me just try. Yeah, I think this was the issue, the double brackets here. So once you fit, unfortunately, like I told you, this sometimes usually underwhelms what machine learning is all about, because this is what is looking for the relationship that is happening in the background. So we want to now see maybe what did it find. So like you remember, so like the formula it's trying to look for is this with the linear regression. So y is equals to mx plus c. So that's what is happening here. And then that is what it's trying to look for and trying to optimize until it finds what is, I think even when we were doing this in high school or university, this is what we're always trying to look for, the gradient. And then also the intercepts. Once you have those two, then you only need x and you get the final y. So next thing we'll do is for the intercept.
Just a minute, James. I did that. I added the brackets.
Yes.
But I'm still getting the same error you are having when you run the linear model.fit.
Yeah. Okay, maybe you can share your screen.
Okay. So I have added the brackets here and the average income.
You've run
it doesn't look like you as why it's green at some point. I don't know if that could be a problem. And then when I run this one.
Mm-hmm. Oh, what happens is
yes.
You see these have numbers. Just scroll up. They have numbers, so the program is sequential, and especially like in Jupyter, it runs in steps. So you have to make sure you run
this one, run the next one,
yes,
the next one, the next one, the next
everything
one.
that is related to it.
Okay, thank you.
Yeah.
And then I saw this. I don't know if we can use this instead. Import sklearn as sk. Will that be used as opposed to importing each individual library and sklearn?
Okay, yeah, I think the only challenge I see with that is your program will end up really big because now you've imported everything. So I don't see a problem with doing that.
Okay.
You can do it, but just know you'll add the program. If you're doing it for deployment, it will be bigger than it's supposed to.
Okay, cool.
Yeah,
cool. So that's fine. Thanks.
Okay. Okay, so just a minute. Okay, anyone with another question? Anyone with a question? Comment. Is everyone following up? Okay. So, okay. Okay, so let me just share my screen. Okay, so back to, so once you now created the, so you already fit the model, and basically what's now within this is the formula to how to be able to correctly predict the y value. So you can actually, if you want to maybe see what's the value of c, so you can actually maybe see the coefficient. So I think you should have one. So, and I think if maybe we were to plot this, what plot this to. You can probably like just do so if you are to do this, if you are to plot this graph here, you check the intercept, you'll see it's actually at that point. So just maybe just draw that line and have a look at it. Just draw the plot. Just the more like a scatter plot of this, and you'll see where it intercepts. But now also, finally, the whole point of doing this is so that you're able to predict. So given a certain number, so so now if I give the model a certain value of X, I should be able to get the, I should be able to predict the final value. So say for instance, should be an array. Let's randomly and see what the value is built in. Okay. But is everyone okay, or has understood what we're doing? Yes.
We were trying to follow.
Okay, just I mean, I don't know why it's something is so it should be predict. But basically, once you have this, because that's the only other concept that maybe you are with y is equals to mx. So okay, this for a different value, but basically that's what we've ended up with in the in that other section, and yeah. Oh yeah, just needs an array. So the one way to split. But basically, okay, this is basically what you do. It's a case that okay, so basically now based on given the value that the model that we've generated, now you're actually able to predict the final value. And yeah, so you're able to predict the final value, and the whole point of splitting was so that we can be able to test. So then the other thing you always have to do in every single model is testing. So just to see what just to see how accurately it actually scored the new values that it's predicted. So you can use this. There is this library here called skline metrics. So within this, it now has all the ones that we had looked at in the PPT. So you can be able to check on root mean square, the root mean square, all these other aspects, and maybe you'll be able to see the confidence level on a specific model you've generated. So okay, so I think maybe for logistic regression, considering the time, I think we've gone past time. But it's basically the same thing. The only difference that comes in is in this section for fitting. Everything is the same. So for fitting, you'll just do the same thing. So yeah, you'll end up with the correct result. I think, unless there is another question, maybe for logistic, we just go through the notebook that I shared. And then next week we just look at classification. So unless maybe there's another question. Please. Any other question? Any question? Timothy? And
yep, okay. Yeah, so I was following up on the other class, but it's fine. Okay. So I think you've given them enough to challenge them.
Mm-hmm.
Yeah, so I'm hoping that they're gonna have the scripts, the notebooks available, and they're going through them one by one. This video will be available for you to listen through and follow. We'll upload it on a private channel on YouTube, so we'll send you that link as well. And James, are you gonna set a quiz?
I think it's more of a challenge on the exercises. Maybe we can follow up on the same. Maybe everyone should do, or should come up with like a hypothesis question and be able to a hypothesis test and be able to predict, maybe based on the data you are using on the previous section.
Okay.
Try maybe make predictions based on linear regression, and also maybe linear regression and logistics. I think should be sufficient. Yes.
Okay. Yeah. So we can look at the other notebook that they were using for the visualization and extrapolate it. Huh?
Yes.
Okay.
Talking about linear and the logistic. When do you apply which one? What factors?
So linear and logistic regression, they are maybe the basic concepts in machine learning, and that's why I think maybe they were taught in high school, and the basics of statistics. So they apply applicable in simple concepts like now what we are saying about weather, temperature. So especially maybe for things that have a very simple relationship and it's usually linear, and there is it's usually linear, that's where that is applicable. But you'll like, this was mostly, I combined this with an intro because they usually very not most of the aspects in now real life or at work, you'll find they are now more complicated. They have the variable, the relationship is not exactly linear. They have a lot of other aspects. So this is first we learn this, and then now we'll now slowly get deeper into the others. But for linear regression, maybe not everywhere, but there are areas where it will be applicable.
Yeah. Okay, and then also just to add to that, you apply it when you don't have a lot of data, and when your data is much cleaner. And you can actually run these models on Excel, so it doesn't need.
Yeah. That's the other thing with linear regression. But,
yeah. But when you get to the other advanced machine learning models, you realize it requires a lot of GPUs to run, and that's why it was good that you introduced the Google Colab. Yeah?
Yes.
All those models, they require GPUs. So the difference between a calculator and Excel is Excel is actually a mini computer. Yeah, so good that you asked that, Steve.
Okay, I think any comment? Okay.
Right. Let me ask something. When talking about the GPU,
yes.
If my computer has one, how can I utilize it? How can I use it instead of the CPU? We can't.
Yes. Okay. Maybe I can share on how to do that, but there are some. Okay, it depends maybe also on the ID that you're using. But yeah, you can utilize the GPU you have, because I think most people don't even really use them for their use. But yeah, and mostly I think, but where I think I see them more applicable is when they are now in parallel, because now they are combined. Instead of just using one, you combine several of them to do a certain task.
Oh, okay.
Okay.
For this, you will not need to do that. So there's sufficient GPUs within the Python IDE and Anaconda enough, and the Google Colab. But when you go to the data engineering, that's when you'll be able to teach you how to set up virtual machines.
Yes.
Yeah.
Okay. So then I think with that we do just like what you've done today. We'll start 30 minutes with just presentations on the exploration and predictions you were able to do. Then we move on to the next.
All right.
Yes.
So thank you all. Thank you, James, for that session. And, keep the interactions, the WhatsApp group, keep making use of it. Yeah. Enjoy your weekend.
You too.
Yeah, thank you so much.
Okay, thank you.